Hi students, we're going to talk about topic 2 today. So graphing piecewise linear functions is what we're looking at here. If all the pieces of a piecewise function are linear, then the function is known as a piecewise linear function. So talking about piecewise is in different pieces, linear is all of them are lines function here. So example 1, using a table of values here. So we have the piecewise linear function given by this information here, again, because x minus 3 is a linear function and 1/2 x plus 4 is a linear function. That's why this is a piecewise linear. And these are over the certain domains. So create a table of values below and graph the function. So from -3 to 0, inclusive of -3, not inclusive of 0. So from here to here, we should be using that first function there. So if I plug in -3 minus 3 is -6, -2 minus 3 is -5, and -1 minus 3 is -4. Then from 0 to 4, we should be using that second function that is there. And so 1/2 of 0 is 0, plus 4 is 4. With a 1 in there, 1/2 times 1 is 1/2, plus 4 is 4.5. Put the 2 in, 2 times 1/2 is 1, plus 4 is 5. 3 times 1/2 is 1.5, plus 4 is 5.5. And last but not least, 4 times 1/2 is 2, plus 4 is 6. So if we're going to graph what we have here, we have a point at -3, -6. So we have a point there. Let's see if I can show all of this. That's pretty good. -2, -5, -1, -4. Now, for this function, it's not at 0, but it does go all the way up until 0. So I'm actually going to solve for this with 0 in there. So 0 minus 3 is -3. So that tells me I also have a point at 0, -3. But that's going to be an open circle. So 0, -3, I'm going to do an open circle there. And then I'm going to show the line that goes through all of that. Okay. Then you have the secondary one, which is from 0, we are at 4. 1, 2, 3, 4. So we've got a point right there. And then 1 is at 4.5, 2 is at 5, 3 is at 5.5, and 4 is at 6. So we have that all there. And it's less than or equal to on both ends, which means they're filled in circles on both ends. And I'm going to connect the dots through there. So that's my linear piecewise function for that one. State the range of f using interval notation. So range is y values. We want to remember that that's what we're talking about there. So if I talk about y values, you work from the bottom up usually. So way down here, we're at -6. So -6 interval notation is inclusive, comma, and we work all the way up to a y value of -3. And we do not include that. So that's going to be an open bracket there or a parenthesis. And then I'm going to put a U, or you can put a comma in there. And then from here, we're at 4, and we go all the way up to 6. And it's inclusive of it. So we're going to do a bracket, 4, 6, and another bracket. So that is my range, which just says that the function is between these different values here within this problem. Okay, so example 2 using forms of lines. Consider the piecewise function given by this. So here's my piecewise function in this. We've got a line for x is less than 2, a line between 2 and 6, and a line for when x is greater than or equal to 6. So less than 2. So less than 2 is going to be over here. If I plug 2 in, -2 plus 5 is 3. So I'm going to have a point at 2, 3. And I'm going to do an open circle there because it's not inclusive of x is equal to 2 there. And -x plus 5, so I know that I would go up 5, 1, 2, 3, 4, 5, and a -1 slope, so -1 over 1 would kind of look like this in here. And it's everything x is less than 2, so from that open circle, I'm going to connect to everything else, and I am going to put an arrow on the end just so we know it keeps going in there. Then between 2 and 6, and inclusive of 2, we should follow the next one. So this one is, if I'm graphing it from -6, -1, so we would go to -6, 2, 3, 4, 5, 6. -1 would be the starting point of it. And then I would have a slope of 1/2 off of that. And I can fill kind of it in. Now, I'm just kind of barely filling this in here because now I got to realize I'm between 2 and 6. So at 2, if I were to plug 2 into this, 2 plus 6 is 8. Half of 8 is 4, minus 1 is 3. So I actually do get to the value of 2, 3 here. And then I'm going all the way to 6. So 2, 3, 4, 5, 6. So this is going to be my open circle here. And I'm going to connect the dots between there. And then lastly, it gives me from x is greater than or equal to 6, the value is -2. So at that 6 value, I'm going to go down to -2, and I'm going to stay flatlined at -2, and it's everything that continues on from there. So this is my piecewise function that can be graphed there. Yes. Use the graph to complete the missing information. So y-intercept it wants to know. So my y-intercept is right here, 1, 2, 3, 4, 5. So my y-intercept is at 5, or you can write that as 0, 5. My x-intercept, if I look along here, there is none. So it never crosses the x-axis. Yes, I know that this red line that I graphed would have crossed it, but it didn't over the interval that we talked about. Global minimum stated as an ordered pair. Just trying to find it. So our global minimum, we would have to say somewhere along here that we're going to hit that minimum. So it's up to you as to what x value that you put in there. But I'm going to just put as 6, -2. But again, that x value could change for that global minimum there. You have lots of them in that case. And then decreasing interval. So for a decreasing interval, it's going to be from here to here. So that decreasing interval is going to be from -infinity all the way to the x value of 2, and that's where it's going to stop decreasing there. So those are the different pieces for that one. Example 3 here, we're going to make our own again, but based on some information given. So a parking garage charges $5 for the first hour. So here's 1 hour, and it's $5 for that first hour. So in that first hour, we're going to include that, and we're going to come across here. If you never park in the parking garage, it's going to be $0. So you could put an open circle there and then kind of go through it. $10 for up to 2 hours. So you're only going to pay $5 if it's 1 hour. $10 for up to 2 hours. So at 1 hour, you're not going to include that. But as soon as you get past that 1 hour, you're going to pay that $10. And that goes all the way up until that 2 hours, and we're going to close that in. And then $12 for the entire day. So $12 is the most. So at 2 hours, we're not going to pay $12. But as soon as we go beyond that, we're going to pay that $12. And this isn't the greatest drawing, but that's the idea for this. Now it says for the entire day, so I guess we'd put an arrow on the end here to include that we're going to keep going from there. So at 0 hours, we would have paid $0. At 1/2 of an hour, at half an hour, we would have paid $5. At 1 hour, we would have still paid $5. But as soon as we went beyond 1, we are paying $10. At 2 hours, we're also paying $10. And then beyond that, we're paying $12. So those are the pieces that would fill that in. Okay, that's it for now.